Hello everyone, we start here with the optical amplifier. We learn in this part the semiconductor optical amplifier, iridium doped amplifier, Raman amplifier, wideband optical amplifier. Now why this optical amplifier is required? Because a given link, it has a power budget, and based on this particular power budget, we are expecting that high level of a signal at the receiver or at the detector. So we need a amplifier for increasing the level of the signal or a photon there. There are the different types of optical amplifier which is used in a link to boost the signal, or after detection we require amplifier. So that is pre-boost, pre-detection amplifier, and we see the types of amplifier there. We learn here what type of amplifier and their gain calculations, and what are the applications of this optical amplifier. Generally, a amplifier are independent of what signal format we are using for transmission, and it is just amplify the signal, and we can define what level we are receiving and what noise is present there. So generally, optical link need to be formulated for a given particular power budget, and in a optical link we use a repeater in between the path so that we can increase the power level there. And the optical amplifier has a large gain bandwidth, and that bandwidth is depending upon the what wavelength that device is used. So optical amplifier used in a conventional repeater to perform the photon electron conversion, or we can use for the electrical amplification, we can use for the retiming, we can use for the pulse shaping, or we can use this optical amplifier to help the electron to photon conversion. So it can use in different applications and for different places there. So for a long distance communication under the sea, or a terrestrial communication, terrestrial point-to-point link, we can use a optical amplifier there. So general applications of optical amplifier, that is to be used a inline optical amplifier, or we can use as a pre-amplifier, or we can use as a power amplifier. So these are the basic amplifiers used in a different purpose or in different places. If you see in a figure A, so it is an inline amplifier, and it is used as a repeater in a long distance communication. So this one inline amplifier is complete total link, optical link from transmitter to receiver. In between that link, amplifier used to amplify the signal level so that long distance communication takes place. Somewhere that optical amplifier used as a preamplifier, that is before detector, means after the link, before the detector, amplifier is used, and because of use of this amplifier before the detector, it reduces the thermal noise of a receiver. So thermal noise is a parameter of an optical receiver. Because of use of this preamplifier, it can be removed. And this inline amplifier, it is totally depend upon the signal level in a given link that is required. So it introduces a lot of losses, so that's why this basic repeater is not used generally in an optical amplifier. A power amplifier, that is a booster or a power booster amplifier, that is used in an optical transmitter to boost the transmitted power. But again, there are limitations for this power amplifier, because a fiber, it has some dispersion occur if the power level increases, and because of that increased power level, scattering occurs, and that the scattering losses occur. So while designing a link, we should consider the aspect of a losses or a noise in the system there. So generally, optical amplifier amplify the signal. Basic operation of optical amplifier: it has a pump source. It provides the energy to the active medium, and then when optical signal propagate through this active medium, and that electron gives or provide the energy to the optical signal, so that amplification takes place. Now, in this optical amplifier, it increases the power level of an incident light through the process of a stimulated emission or an optical power transfer. And this device absorbs energy supplied from an external source, that is a pump, that is active medium, absorb the energy from the pump. So the pump supplies the energy to the electrons in an active medium, and that raises their energy level to produce a population inversion. When an incoming signal propagates through the active medium, then this photon trigger this excited electron to drop to the lower levels through a stimulated emission process. So incoming photon, that is from the optical input signal, stimulate a cascaded effect in which many excited electrons emit photons of equal energy as they drop to the ground state, and which result in a optical signal amplification. So the various optical amplifiers are there, and for each and every optical amplifier, what active medium we are using and what is the pump source used in the amplifier. It gives us the amplification. So here the different types of optical amplifier structures and their operating region. This one is structure, their different structures are there, and this different filter. So here a gain clamped semiconductor amplifier used in O band and free band. This amplifier O band. So we learn here iridium doped fiber amplifier which is used in a C band, and a Raman fiber amplifier which is used in the band of 1260 to 1650 nanometer range, in which that is the third window. So this one is about a Raman fiber amplifier. So as I told you earlier, an optical amplifier, it has a optical amplifying medium. So the process of amplification by stimulated emission or by stimulated scattering gives us the types of the or categorize the optical amplifier. There are two main categories of optical amplifier, that is semiconductor optical amplifier and a fiber amplifier. So that in which a scattering or a stimulated emission from the injected carrier takes place. We see here a semiconductor optical amplifier, and if you see that here the active region, and that active region is in between the P-type and N-type material, with light propagating through the active region, and this one is about a light out from this active region. This semiconductor optical amplifier is designed using a indium gallium arsenide phosphor laser, and that is operating below its threshold point. So it operates in a narrow wavelength band, that is given wavelength region, and this semiconductor optical amplifier belongs to a traveling wave amplifier category. Means your light propagates through this active medium. In the propagation of a light, it amplifies the optical signal. Or we can say that when a signal travels through this active medium, then that active region or a cavity, it amplifies the signal. And this passage gives or provide the energy to the optical signal. You see that here, that is a active medium, it has a length, width and a height, and the end facets, it has a reflectivity, that is this one from the end, this end and that end, it has having the different reflectivities there, and these reflectivities are around 0.3, and if that reflectivity is lower, then optical signal can propagate through this active medium, so that we can use the amplifier for the condition of a low reflectivity.